Question number 22, when we need to figure out the magnitude of acceleration. Well, first we need to find the resultant force acting on the car. And mind you, this is just about the forces that are given here. We're not looking at force of gravity, air resistance, or anything like that. We're just looking at the forces that are shown in the diagram. They're not perpendicular to each other, therefore we're going to use our x and y component method, add x's to x's, y's to y's, and go from there. So for x direction, I see 450, which is going to be negative because it's to the left. So negative 450 times sine, because it's opposite, of 10. And then the second one is positive because it's pointing to the right, and it's 380 sine of 30 degrees. These are my x components, and when I put them into the calculator, that'll be 190 minus 78.1. That is 111.9 newtons. I mean, you can just do 112 newtons. That's perfectly fine. Then as far as our y direction goes, both the components are pointing north, so they're both positive. So I will have 450 cosine of 10 and 380 cosine of 30. That gets me 443.2 and 329. When I add them, I get 772. I can just round the 3 off. So then I would get my resultant force pointing like this. I have 112 to the right, 772 up. Then I will do Pythagorean theorem for this. The resultant force is going to be 780 newtons. After I do 772 squared plus 112 squared. And what is important is, because they want magnitude and direction, I also have to figure out my angle, which will be the arctan or inverse tan, north over east. So 772 over 112. That should get me 82 degrees, and it's going to be northeast. And then eventually for B, if the car's mass is 3,200 kilograms, then I go ahead and take my force, which is 780 over 3,200. That gets me 0.24 meters per second squared acceleration at 82 degrees northeast. And that's how you solve that problem.